Hello everyone. For my presentation, I will be presenting on the topic of feature encoding. Feature encoding is the process of converting categorical variables into numerical variables. Most algorithms cannot handle categorical variables, so they are converted into numerical variables. And feature encoding is used to convert the category into numerical values. And there are many encoding techniques that are used to convert category into numerical variables. They are label encoding, ordinal encoding, and one-hot encoding, binary encoding. So we'll be starting from ordinal encoding. Ordinal encoding, ordinal encoding, we'll have to define an order which the program will then assign to each values in the dataset. In my dataset, I have taken encoding data CSV and it has the columns ID, bin1, bin2, nom0, and OD of 2. So we have assigned our values for hot, warm, and cold as 0, 1, and 2. Now, when we use our before start executing our program, we have to import the label encoder and ordinal encoder from SQL under pre-processing. After we have assigned the order, we execute the program using E1 is equal to ordinal encoder, category is equal to P of M, which is used to assign the values. Once you execute the program, we get the output in this column BO of 2. So it assigns values for hot as 0, warm as 1, and cold as 2. So once we execute the program, we get the following output. It's hot is equal to 0, warm is 1, cold is 2, warm is 1, and cold is 2. And next, we'll be seeing about label encoder. So coding we'll be seeing is the label encoder. In label encoder, the label encoder itself assigns the values for the dataset values, and here we'll be using the code. First, we'll be using the label encoder. We use the same copy of our dataset, and when we run the program for OOD of 3 is equal to le.fit underscore transform BFC of OOD of 2. Our OOD of 2 column has hot, warm, and cold. When we run the program itself assigns the values for cold is 0, warm is 1, and warm is 2, and hot is 1. So when we run the program, we get the output as for hot we get the output as 1, for warm we get the output as 2, and for cold we get the output as 0. Now the next input in now the coding. Then one hot encoding, for each category value we create a new variable which creates a new column. So here 0 represents the absence and 1 represents the presence of that category. And in one hot encoding we use the following code. First we import our one hot encoder from SQL under pre-processing once again, and use the following code. OH is equal to one hot encoders, pass is equal to false, and use the same copy of our dataset, and we execute the program using the following code. ENC is equal to pd.dataframe, and OH is equal to fit underscore transform df2 of nom of 0. So our nom of 0 has the following values. They are red, blue, and green. And so once when we run the program, it creates a variable for red, blue, and green. And here it has assigned for red it has assigned 2, for blue it has assigned 1, and for green it has assigned 1. And for here for red it has assigned 2, for blue it has assigned 0, and for green it has assigned 1. So when we see in the NOM0 column, it has red in the first column. So first row it has red. So in 2 we have 1.0, and in the second row it has blue. So we have in the 0 we have 1, and in the third row we have green. So it has 1 in the first column. So this is how one hot encoding works. So the next encoding which we'll be seeing is binary encoding. Binary encoding assigns binary values. They are zeros and ones. So here we can see the example. For hot it has been 1, for cold it is 2, and for very hot it is 3, and for warm it is 4. Which it converts the 1, 2, 3, and 4. It converts it into binary values. They are 001, 010, and 011 till the number of data we have. So in my data set I'll be using data.csv. It has columns ID, bin1, bin2, city, OD1, OD2, and target. So we'll be first using from category encoders, we'll be importing binary encoders for using our binary encoder, and we'll be using the following code. ND is equal to b.fit underscore transform df ODF. So our ODF2 has high school, master's, diploma, and bachelor's, which the code assigns values as 1, 2, 3, 0, 1, 2, 3, So when we run the program, we get the following output, that is OD of 0, 1 and 2, which so for high school we assign the value as 1, that is 0, 0, 1. For masters we assign the value as 2, which is 0, 1, 0. For diploma we assign the value as 3, 0, 1, 1. And for bachelors we assign the value as 1, 0, 0, which is 4. So the program repeats in the same way. For bachelors again we have 4, which is 1, 0, 0. For masters it is 3, so it is 0. For masters it is 2, so it is 0, 1, 0. And for PhD it is 5, which is 1, 0, 1, which is the fifth value. And the next encoding which we'll be seeing is target encoder. So target encoder uses the following code. We'll be once again importing from category encoders target encoder. P is equal to target encoder. We use the same copy which is our data.csv folder, dataset, data.csv dataset, and we use the following code. New is equal to t dot fit underscore transform. X is equal to cc of city, which is our city column, and y is equal to cc of target, which is our target column. So once when we run the code, we get the following output for target and city, which is converted using target encoder. We had in the first column we had it as 0, 1, 1, 0, 1, and city is Delhi, Bangalore, Mumbai, and Chennai. But once when we run the code, we get the output as city has a specific range from 0 to 5, 0 to 1, and target has 0 and 1, so it is automatically assigns us only 0 and 1. Thank you.